In this session, we are going to look at the S bar R bar latch. We already discussed the introduction to the latches and flip-flops and also the SR latch in the previous session. So if you are new to the latches, you better visit that session and return to this one. The link is available above in the screen. S bar R bar latch is pretty much similar to the SR latch. The best way to understand the S bar R bar latch is compare it with the SR latch, which we have already discussed. So let's do the comparison. The SR latch consists of two NOR gates, whereas the S bar R bar latch consists of two NAND gates. We are using slightly different notation in S bar R bar latch. So rather than the R, we call it S bar. Rather than S, we call it R bar. And you can see that it is just to give it a different name. We know that the set is the inversion of the reset. Reset is the inversion of the set. So therefore, rather than reset, we can call it S bar or the inversion of set. Rather than set, we can call it inversion of the reset. The truth table of the SR latch and S bar R bar latch is pretty much similar. So the first difference is in SR latch we call the two inputs as S and R, but in S bar R bar latch S is called R bar, R is called S bar. Other than that, it is pretty much the same. And when it comes to setting the SR latch, we used to give S equal 1, R equal 0 input combination. So in the S bar R bar latch, so rather than S we call it R bar. So you can see that we have to give R bar equal 1, S bar equal 0 combination. It is pretty much the same combination with two different notations. In SR latch, when we want to reset the value, we used to give R1 and S0. In S bar bar latch, because R is called S bar, we have to give S bar 1 and R bar 0. And the second difference between SR latch and S bar bar latch is when we want to retain or memory, in SR latch we used to give 0-0 combination. Whereas in S bar bar latch, in order to retain the value, we give 1-1 combination. And in SR latch, 1-1 happen to be an invalid combination. And similarly, in S bar R bar latch, the 0-0 is the invalid combination. Now let's look at the possible outcomes of the S bar R bar latch. And obviously one outcome is the set value Q equal 1, Q bar 0. The second possible outcome is the reset value or the Q bar 1 and Q 0. Then there are two invalid possibilities, that is both Q and Q bar 1 is invalid scenario, both Q and Q bar having 0 is another invalid scenario. Because in a latch, the Q and Q bar must be having opposite values. Now let's first look at how to set and remember a bit in S bar R bar latch. The functionality is pretty much similar to the SR latch. So in order to set 1 in SR latch, we used to give S equal 1, R equal 0. So in S bar R bar latch, we call it R bar equal 1 and S bar equal 0. In SR latch, the retention was done by having both S and R 0. In S bar R bar latch, we have to retain it by using S bar 1, R bar 1 combination. Now let's look at how does the sequential logic circuit for S bar R bar does this functionality. So in order to set the bit to 1, we have to give R bar 1, S bar 0 combination. And in order to understand the S bar R bar latch set functionality, we have to look at the truth table of the NAND gate, because we are using two NAND gates. And if you analyze the truth table of the NAND gate, you can see that if at least one of the input is 0, the output is guaranteed to be 1. Whereas if both inputs are 1 only, the output is 0. Therefore, when it comes to input 0, if we can see that at least one input is 0, we can say that the output is 1. But when it comes to 1, we have to check both the inputs, and if both are 1 only, we can say that the output is 0. So this is the logic that we are going to use to understand the functionality of the S bar latch. Now again we are using these bulbs to denote whether it is 1 or 0. That is just to visualize it better. Right, now we have S bar 0, R bar 1. So we are supposed to set it to 1. Now let's see how we going to set it to 1. And in the truth table, you can see that if at least one of the input is 0, the output is 1. And for this NAND gate, already one of the input is 0. So therefore, definitely the output has to be 1. But still we can't figure it out what is the output of this particular NAND gate, because we have to look at both inputs to determine whether it is 0 or 1. But once we get 1 as the output in the first NAND gate, we know that that is fed it to the input of the second NAND gate. Now we are in a position to say when both inputs of the NAND gate is 1, the output is 0. So therefore now we know that this is going to be output as 0. And that 0 will be fed it to the input of the first NAND gate. And it doesn't matter, when both are 0 also, the output is 1. And that one is fed it to the second NAND gate. When both are 1, the output is 0. Now you can see that it has saturated and it has stabilized so that your Q is 1 and your Q bar is 0. So therefore we can say that when we have R bar equal 1, S bar equal 0 combination, we are setting our S bar R bar latch to 1. Now let's see how to retain this value. In S bar R bar latches, we retain the value by setting both S bar and R bar to 1. Now we have set both S bar and R bar values to 1. Our latch was in the set state, that is Q is 1, the Q bar is 0. So we have to consider that the previous outputs values in order to understand the retention value. And again from the truth table, you can see that when at least one input is 0, the output is 1. But here none of these inputs are 0. But we can see that this particular 0 is fed into the first NAND gate. So therefore, now we have a situation where one of the input is 0. When at least one of the input is 0, output is 1. So therefore we get 1 here again. And that one is fed it to the second NAND gate. And here we have the 1-1 combination which results in 0 as the output. So therefore again we get 0. And that 0 is fed it here. That results in 1. And that 1 is fed it here. And 1-1 result in 0. And you can see that even though we have set both S bar and R bar to 1, still our S bar R bar latch retain the Q equal 1, Q bar equal 0 combination. So that means it has remembered that the value of the latch is 1. Now let's move on to how to reset the S bar R bar latch into 0. In SR latch, we used to reset the latch by setting R equal 1, S equal 0. But in S bar R bar latch, the R is called S bar. So therefore we have to set S bar equal 1 and R bar equal 0. And in order to retain, in SR latch, we used to give both S and R 0. In S bar R bar latch, to retain, we are going to give both S bar and R bar 1 again. Now let's see how it works in the logic circuit level. So we have set the S bar equal 1 and R bar equal 0 so that we want to reset it to 0. Now again from the truth table, you can see that when at least one input is 0, output is 1. Here we have input, one of the inputs 0. So therefore this second NAND gate's output is guaranteed to be 1. And that one is fed it to the first NAND gate. And when 1-1 input combination is given, the output is 0. And that 0 is fed it to the second NAND gate. and it doesn't matter, even when both are 0, the output is 1. Now it keeps going on and it stabilizes to the Q equals 0, Q bar equal 1. So the Q equals 0 means we have reset our S bar R bar latch. Now let's see how to retain the values. So what we have to do is, while the latch is in this particular state, we are going to set both S bar and R bar to 1. Now remember, the output is now Q0, Q bar 1, and now we have set both values to 1. Now again, let's see how the circuit is going to be stabilized in sequence. Again, we have to look for the scenario where at least one of the input is 0, because both the inputs are 1. Here we have the output 0 that will be fed it here, and now we know that one of the input is 0 means this NAND gates gives the output 1, and that one is fed it to the first NAND gate, and when both are 1, the output is 0. So therefore it retains the reset value of 0, and that 0 is fed it here and we get 1, and so on. So even though we have changed our S bar and R bar to both 1, it keep retaining the Q0, Q bar 1 situation. That means now it remember or retain the reset state. So that is how we reset and remember in S bar R bar latch. Now let's move on to the invalid scenario for S bar R bar latch. Remember, in the SR latch, when both S and R are 1, we get into an invalid scenario. In the S bar R bar latch, we are getting to a similar invalid scenario when both S bar and R bar are 0. Now in this circuit, you can see that both S bar and R bar values are 0. Now if you look at the truth table for the NAND gate, again you can see that when at least one input is 0, the output is 1, and that is exactly the case here. We already know that one input for this NAND gate and the one input for the second NAND gate is 0. So therefore it is guaranteed the both outputs are 1. And this one is fed it to this NAND gate and this one is fed it to the other NAND gate. Now again, when 0-1 combination or 1-0 combination, the output is 1. So therefore this is going to keep getting both Q and Q bar as 1. So Q and Q bar both getting 1 is invalid, because it must be Q bar must be the inversion of the Q. So therefore in S bar R bar latch, having both S bar and R bar 0 is an invalid input combination. That's it about the S bar R bar latch. The functionality was pretty much similar to the SR latch. So therefore it's very intuitive to understand the S bar R bar latch if you have already understood the SR latch. If you find this session interesting and useful, make sure you like it. And if there is anything that you want to clarify or something you're not very clear, make sure you comment it so that I can help you. If you want to get the notification of future sessions, make sure you subscribe and enable the bell icon. Thank you.